All right, we're going to keep going here. We're on Unit 4A. We're on the second day of day 2, second part of day 2. This is, after this, we are going to have a quiz, so this, we're going to kind of take a little break. Tomorrow you'll have a quiz review. It's on Canvas. So yeah, you can work on that. And then the next day will be a quiz over days 1 and 2 in their entirety. So 1A, 1B, 2A, 2B. Anyway, so we're going to continue on here with the trig, and just know that with the unit circle, we do not expect you to look at it and have stuff memorized. When we ask you questions, like if I ask you the cosine of 45, it's okay to think about it for 10 or 15 seconds and draw stuff out and find it. It's not something you're supposed to just look at it and get. I know sometimes in math we can do that, but these are not the kind of problems we expect you to just look at it and be like, oh, that's radical 2 over 2, or whatever it might be. So, our learning target here, we have 3 of them. I can evaluate trig functions given radians or degree measures. Kind of been doing that already. I can find a given side or angle using SOHCAHTOA, or this guy. I won't even try to say that. But these are just reciprocal functions. And that's mostly what you did in geometry. So hopefully some of that is just review. Like you'll think, oh, I remember doing this, and geometry wasn't too bad. Probably a couple years ago you took that. And then I can set up and solve an application problem using trig. So without using a calculator or a unit circle, so no unit circles here, can we just start from scratch? Can we evaluate the following? Then we're going to use our calculator to find it, just to make sure we got it right. So like I said on this one, I don't expect you boom, have the answer. If you do, that's awesome. Some of these you will start remembering the answer. But just, if cosine 45, just draw a 45 degree angle here. That means you have a 45, 45, 90. If this is a unit circle, that's 1. That means this is divided by radical 2. So the sides, the legs would be radical 2 over 2. And then if this is theta, well, the cosine ratio is adjacent over hypotenuse, to be radical 2 over 2. Okay. Now notice on here, it does talk about changing the mode when needed. Okay, so changing the mode when needed, this is degrees. I got 45 degrees, so I got to go to mode and make sure that it's in radian. See this? My computer froze. There we go. So radian degree. So right here, I could do radian or degree. Well, I'm going to give it degrees, so I need to tell the calculator it's in degrees. This is a huge difference. You get 2 different, most of the time, totally different answers depending on what mode you have it in. Okay, so cosine 45, as long as I'm in degree mode, I got 0.707. Is that the same thing as radical 2 over 2? Pretty easy to check. Yes, it is. Okay, so number 2 says the cosecant of 60. So first off, let's think about that 60 degree angle. And 60 is good because that makes a 30, 60, 90 triangle. And so if this unit circle, the hypotenuse is 1, so this would be a half, and this would be radical 3 over 2. And now cosecant, if you remember cosecant, is going to be the reciprocal of sine. So if I can find the sine ratio, I'll just flip it over basically. So the sine ratio is opposite of hypotenuse, so that'd be 1 over radical 3 over 2. And if I flip that over, that'd be 2 over radical 3. Rationalize it, and you get 2 radical 3 over 3. Put it in the calculator and check it. I'm going to save some time here. We know how to put degrees in the calculator. Now, tangent of pi over 6. So what is pi over 6? Again, my quick way of converting is take out pi and put 180 in its place. So 180 divided by 6 would be 30. So I've got, well, not that one. Sorry, so I was thinking this was a 30 going back in my mind. So here, let's do this. So 30 degree angle. This is a 1. That's a 1/2. This is radical 3 over 2. The tangent ratio is going to be opposite over adjacent. So 1/2 over radical 3 over 2. And then we said if they're over 2, just cancel them. So it's just 1 over radical 3, which would be radical 3 over 3. If I want to check that in the calculator, and this one is in radians, so I go back to push mode and put this back into radians. And now I want the tangent of pi divided by 6. I get that answer. Well, let's just take the square root of 3 divided by 3, and it's the same thing. So we double checked it, and I do have it right. Given this idea, this information that the sine of theta, so there's some angle, the sine ratio is 5 over 6. We're supposed to set up a triangle and evaluate the remaining trig functions, leaving the answers in simplified radical form. So we don't need decimals, we're going to leave it in radical form with no radicals on bottom. So I've got this triangle. That's a terrible triangle. They didn't meet at the corner there. We'll do this. And here's my theta, and sine is opposite over hypotenuse. Okay, so opposite must be 5, hypotenuse is 6. I do want to mention, we're not going to worry about it just in this lesson just yet, but technically, the ratios are going to be essentially the same, but this could be on the other side. You think of the unit circle here. I know that's a 6, it's not a 1, but it could have been going this way. We're talking about the unit circle. But since we're really just solving a problem, we're not worried about negatives, positives, because it could be like this, 5 over 6, the sine ratio is still 5, 6, and that is still technically true. This might be a negative value, that'd be a positive value, but we're not really using a unit circle. We're going to use acute angles here in doing this. We're just going to say this is a less than 90. I'm going to open this thing all the way up over here, kind of ratio. So if you're thinking that, we will account for that in the coming lessons. But for right now, because like I said, this information tells us one of these two triangles on the unit circle, but we're not really in the unit circle. We're just a triangle that exists, and we're using acute angles. So if this is 6, this is 5, we need to find that last side. So use Pythagorean theorem. So 6 squared minus 5 squared, and I'm going to square root that. I'll just put radically 11. So this side is radically 11, and then start writing them in. So cosine's adjacent over hypotenuse. Tangent would be opposite over adjacent. That's 5 over radical 11, which would be 5 radical 11 over 11. Now secant, remember, is a reciprocal of cosine. So I'm just going to flip this over. 6 over radical 11, which is 6 radical 11 over 11. Cosecant is the reciprocal of sine, so 6/5. Cotangent is reciprocal of tangent. So I'm going to go back to this one and flip that one over. So radical 11 over 5. Save some time. Because I could write this one down, flip it over, and then rationalize and simplify, and I'll get this. So it'd be kind of silly to do all that extra work. Not every situation has a special right triangle. So 30, 60, 90, 45, 45, 90, those are really nice to work with, but this one's a 51. If that's 51, that means this is 39. Remember, they have to, if it's a right triangle, these two are complementary, they add up to 90. So this one's not a special. I don't know the ratios. I can't do 1, 2 radical 3 or 1, 1 radical 2 or anything like that. So we'll recall how to use a calculator to solve problems with the measurements in degrees or radians. So it says with your group. In a given year, we'd have a group, but we're supposed to solve the triangle. So remember, solve the triangle means find all the sides and angles. Well, the missing angle B was one of the missing angles. That's 39. We're also missing side AB and side AC, or CA, however you want to say it. So first off, lots of ways to do this. Okay, I'm going to set up one way. You could set up a different way and get it. So I'm going to look at from 51's perspective to find AB. So this would be, I'm going to do sine. So sine of 51 equals opposite over hypotenuse. So 9 over x. Actually, I'll just say 9 over AB. And if I'm solving for AB and it's in the denominator, a real quick trick is just flip-flop these guys. So AB and sine 51, flip-flop them. Because when I multiply both sides by AB and then divide by sine 51, that's all I did. So AB equals 9 divided by sine 51. Make sure these are in degrees, so make sure you're in degree mode. So I'm changing back to degree mode, and I'm going to do 9 divided by sine 51, 11.58. And then I can stick with from 51. You could also use 39 to find AC. We could do sine of 39 equals opposite of hypotenuse. Opposite of hypotenuse, which we just found was 11.58. We could do cosine over hypotenuse. We could do tangent. We could do all kinds of stuff. I'm just going to stick with 51. I'm going to do cosine 51. So that's adjacent over hypotenuse. So adjacent is AC, hypotenuse. We just found 11.58. So if I multiply that over, 11.58 cosine 51 will equal AC. You can just type it in. You don't have to put a multiplication sign there if you don't want to. In fact, I'm going to use this previous answer. I'm going to go second answer, cosine 51. So it's taking 11.58 cosine 51. That means multiplying together, 7.29. Okay. That did not fold very well. Okay, fire department. The longest ladder is 110 feet long, but their safety regulations state that they can only use it to rescue up to 100 feet. If you go any higher than that, it's not safe. The ladder could fall backwards, you know. So plus 100 feet is pretty high on a ladder. What is the maximum safe angle of elevation for this rescue ladder? So we can't put it straight up and down. Obviously, that'd be 110 feet. So there's this building standing up. We're going to lay the ladder up against it. It can only be up to 100 feet. The ladder can touch the building 100 feet off the ground, but it is 110. And what's the maximum safe angle of elevation? So that's this guy right here. So I'm trying to find an angle. Again, I shouldn't say again, I haven't said it yet, but don't forget this is DMS form. So I'm done. I got to make sure I have degrees, minutes, seconds. When I have an angle, I don't use the sine, cosine, tangent function on the calculator. I use the second, the inverse, because I'm going backwards. I'm giving it the ratio, and I want to find the angle. So first off, this guy here, I know the opposite, I know the hypotenuse, that's sine. So sine of this angle is 100 over 110. So to type that in the calculator, I'm going to do inverse sine. So I'm telling the calculator, I'm not going to give you the angle, I'm going to give you the ratio. You give me the angle, go backwards. The ratio, which you can reduce this to 10 over 11, or you can type in 100 divided by 110, and hit equals. And it's a 65.38, I'm going to leave it there, 38. And now I need to convert that to degrees, minutes, seconds. If you remember, this is 65 degrees. I'm going to take 0.38 times 60. That equals 22.8, so it'll be 22 minutes. I'm going to take that 0.8 times 60, and I get 48 seconds. Now, why a fireman would want it in degrees, minutes, seconds, I don't know, but we're going to go with it. See, Ophelia Payne is walking to her office building, which she knows is 150 feet high. So here's an office building, 150 feet high. The angle to the top of the building from her location, now this is from her feet, not from her head, is 6 degrees. So it's actually way back here somewhere, but this is not drawn to scale. I'm just going to put it here. So this angle of elevation is 6 degrees. How much further does she need to walk? So how far away is she from the building? Opposite side, adjacent side, that's tangent. Tangent 60 equals opposite over adjacent. Again, when the variable's on the bottom, just flip-flop. So this would be x equals 150 divided by tan 60. And when I put that in the calculator, I'm sorry, 6 degrees. Tan 6 degrees, good grief. So 6 degrees, 150 divided by tan 6. And we need to be pretty far away because it's a very low angle of elevation. So she must be really far away that she's only looking up 6 degrees off in the distance. And so this should be a big number. And when I put in the calculator, 1427.15, it doesn't say to round, so I'll just leave it as a decimal feet. Okay, last one. A submersible traveling at a depth, so that's underwater. It can go underwater like a submarine. It's traveling at a depth of 250 feet, and then it dives at a 15 degree, let me erase this, 15 degree, 10 minute, 50 second degree angle with respect to a line parallel to the water surface. It travels for a horizontal distance of 150 feet. What is the new depth? So first off, here's the water. Here's that parallel line where it started, and this is 250 feet. Then it decides to go down at an angle of 15 degrees, 10 minutes, and 50 seconds. So 15 degrees plus 10 over 60 plus 50 over 3600. Type that in the calculator, that's 15.18 degrees. So it says 15.18 degrees. Now I traveled a horizontal distance. So this side is 1500. I want to know first off what is this side, and I need to add 250 to it. Okay, so I got my angle opposite over adjacent, that's tangent. So tangent of 15.18, that's going to equal opposite over adjacent. And so it'd be 1500 tan 15.18 equals x. And then I don't want to forget to add, I'll just add 250 to that to get my final answer when I'm done here. So type this on the calculator. I get 406.97. I'm just going to round the nearest foot. I guess I didn't say that, but I did. So round the nearest foot, here, add this up. So 657 feet now. That's the total depth after it dove that far. So hopefully that makes sense. Hopefully a lot of this was review for you, and probably rung a bell, hopefully. But let me know if you have any questions.